For more than 80 years, your Colorado River District has been working to safeguard West Slope water and keep our water on the western slope. Our rivers provide clean drinking water for our families. They create jobs and put food on our tables. That's why the Colorado River District works every day to protect our water and our western slope way of life. Because this is your water, these are your rivers, and this is your Colorado River District.
Good afternoon, everybody. My name is Jim Pokran. I am the Community Affairs Director of the Colorado River District, at least for 15 more days. I'm calling it quits on the 31st of December, and I'm going to become an intensive snowpack investigator, which some people might call I'll be skiing a lot. Welcome to Water with Your Lunch. This is the 7th in our series of webinars, which we found in this pandemic era as a great way to reach out to people and talk about important water issues in the West. In fact, we found that we reach more people by Zoom than we do with some of our live events. So here we go. The little advanced arrows, sorry about that. So what is the Colorado River District? We work to protect West Slope water and keep your water on the West Slope. And why do we do that? It's because other people want it. And as we go through the balance of this webinar, we're going to find out how we get the water, why it's here, and a little bit more about what happens from the time the snow falls to the time it melts off. Basically, the premise of this webinar is we're all snow farmers. So snow is the crop and the harvest is runoff, and the runoff is our water supply. And here in the arid West, if we didn't have this dynamic of snow falling above 9,000 feet and accumulating in copious amounts, we always hope we all wouldn't be able to live here. So here's the River District coverage area. It's 15 counties in northwestern Colorado, from the north slope of the San Juans, the Wyoming border, the west side of the Continental Divide, and the east side of the Utah border. And we were formed to lead in the protection, conservation, use, and development of the water resources of the Colorado River Basin. This is kind of work that we do as we've entering almost our 85th year. We work to keep water flowing to farms and ranches, secure legal protections to keep water on the West Slope. And again, that's because it's much desired elsewhere, for instance, on the Front Range of Colorado and in the lower basin states. Maintaining healthy rivers and ensuring adequate drinking water supplies is our modern day work. So this is the setup. The rest of the conversation. This is the average annual precipitation in Colorado. So, you know, reds and yellows and browns are not good. What we're really talking about is the snow that falls in those areas that are purple. That's not a great part of the landmass in Colorado. And we, as we'll talk about here in a second, think about these areas in Colorado, because this is what supplies about 70% of the water to the whole Colorado River Basin. And believe me, the lower basin states are looking continuously at what's happening where you see these purples. So this just shows, when you think about that former slide, this shows you how that water comes into play. So this is the whole entire Colorado River Basin. We're in the upper basin, of course, in Colorado, and you can see the percentages of overall supply from the upper basin versus the lower basin. What I'd really like to point out here are the areas in gray or dark gray. This is where water is exported from the Colorado River Basin to the Front Range of Colorado, the upper northern Front Range, even Cheyenne and Wyoming, the Arkansas Basin, New Mexico, Salt Lake City area, and the Colorado Southern California, where the Colorado River Aqueduct takes water over to the cities, and the Imperial and Coachella irrigation districts take copious amounts of water from the river itself. So a lot of people want our water, and keep in mind, Western Colorado is the #1 water producing watershed in the basin. This is Lake Powell is a great way to look at our hydrology in the basin and what the snowpack's been doing over time. So this is Lake Powell since the time 1964, when it started filling through the predictions for the present. Just point out 2002 and 2018, two of the poorest years, 2002 being the worst. And what folks at the Western Water Assessment, which is a NOAA operation based at the University of Colorado in Boulder, are saying that the start of this water year right now is on par with just a little bit better than 2002. So of course, we've been talking about this a little bit, and we're finding that, hey, it's starting to snow. So I hope that we get a little reverse psychology from this webinar and things really turn around. But suffice to say, as we'll hear later, this has been a slow start to the snow year. And here are the other problems. Drought. Reds and browns are bad. Look at Western Colorado. Look at the whole Colorado River Basin. This is not a great platform for this snowpack that we're hoping increases. This bespeaks dry soils, and dry soils make for an inefficient runoff, and the drier the soils, the longer it takes the melting snow to reach the stream. So droughts is a bad start. Here's another long-term problem, according to NOAA, and this is the Colorado River District. Since 1895, temperatures are warming. Up where Allen HENCEROTH is, 1.9 degrees on average. And you can see Pickens County, Eagle County, where the ski resorts are, route where Steamboat is. But look at the western areas, which are actually, the heart of the agricultural areas. This is a chief hotspot for us, but also for all southwestern Colorado. And for every 1 degree Fahrenheit rise in temperature, scientists say stream flow is reduced between 3 and 5.2%. So with that said, we're going to hear from Joel Gratz of OpenSnow. He's going to talk to us about his ability to forecast mountain snow and how we all can learn from that. So in a sense, he's going to talk about forecasting the size of the crop. Then Paul Miller, a hydrologist with the Colorado Basin River Forecast Center, is going to talk to us about how the size of that crop is converted into runoff, i.e. our water supply. Then we're going to have a discussion of how snow affects our winter economics and our summer economics with Alan HENCEROTH. He's Chief Operating Officer of ARAPAHOE Basin in Summit County, which likes to be the first to open and the last to close. And then we're going to hear the agricultural perspective with Todd Hagenbu. He's with the Colorado State University Extension in Routt County, and we're going to talk about how the crop gets put to use on the crops that we eat. So Joel, take it away.
Perfect. Thanks for that intro. I'll try to give good news.
We need it.
Yeah, 2020. We could always use some good news. So thanks for joining me. This is, I love water. I'm concerned about water, but my primary job responsibility and passion is what comes before water here in Colorado, which is snow. So let's get into the snow. And give me 1 second to start going here. There we go. So what I love to do is ski deep powder. This is what got me into this. Now, I went to school for meteorology, and so I love more than powder. I love all of weather, but skiing powder is my passion. Finding spots in the backcountry and in resorts with 18 fluffy inches of snow. This is what I live for. This is what I dream about. every day pretty much of the year. So let me do a very quick background on me, and we'll get into what the season might hold in terms of snow. I was a skier since age 4. At the same day I started skiing, I started loving the weather because you can't ski without cold temperatures and some snow. I grew up ski racing back on the East Coast, so I was very familiar with ice and snowmaking temperatures. I was not very familiar with powder. I went to Penn State for meteorology and pursued that, and that's what I wanted to do really since I was 4 years old. So lived the dream, got a meteorology degree. My first powder day wasn't until I was about 20 years old, and then I discovered there was more to skiing than loose granular. Nothing against the East Coast, but opened my eyes. And then when I moved to Colorado, I missed a foot storm, and then a year later, I missed 48 inches up in 48 hours up at Steamboat. And as a meteorologist, I just got really mad because the forecast was so wrong, and I couldn't understand how on earth we could have a forecast for maybe 6 to 12 inches, and we got 4 times that amount. I know forecasts aren't always correct, but the size of the forecast bust surprised me. So I figured out a couple things over the ensuing years. One, maybe how to forecast a little bit better, and 2, how to be in true Colorado fashion and ski in a onesie with no shirt in the spring. Feels like a rite of passage. But anyway, those missed powder days set me down a course of using my meteorology degree to figure out how to best forecast snow here in Colorado. And then this is just a brief history of the growth of OpenSnow, which is a business that I started about 13 years ago. And it was just a little email list with 37 people 13 years ago, and grew into a blog and then a full-fledged website now, an app at OpenSnow and OpenSnow.com, and pretty excited to reach a couple million skiers and riders across mostly the US who are looking for good snow forecasts and to learn, most importantly, just a little bit more about the science. So enough about me. Let's get into the snow. And before we look ahead, the first thing we always do in meteorology is look current and behind, actually, to understand how we got here. So let's take a step back and look at what happened last year. Last year was, by all accounts, or last season, I should say, a pretty good season from a snow perspective. At the end of March, we wound up with near average to slightly above average snowpack across the state. That's great news. We all want way above average snowpack, but even average here in Colorado is pretty good in terms of skiing and also in terms of water. Let's look briefly at the details of what happened last year. So to set this stage, this is snowpack across the state of Colorado. So all the stations kind of average together. It starts out as 0 at the bottom left. It grows until it peaks in late March and early April there in the middle, and then it quickly melts out down to the bottom right. You can see all the various lines and colors are the basically everything that's happened over the last 30 plus years, the low years, the high years, everything in between. That green line is the median. So roughly the average, although slightly different than the average, but in rough accounts, the average. And that red line kind of going, squiggling up through the middle was what happened last year. So we had a quick start in late October. Then we flatlined. That where the line goes left to right is where we have little or really no snow happening. People kind of freaking out at the beginning of the year. And then the best part of last year was that for most of the year, that red line went up and to the right consistently, no long dry spells. So we stayed near or above average snowpack for most of the year. And then we did have a warm end of the season into May. So we had a slightly faster meltout than is average. But overall, last year, roughly around average, and that's pretty good. So where are we currently? Well, not so good. The numbers on this map show the percent of average snowpack, and for most of the state, and including the Colorado Basin, we are about a quarter below average, so about 70–75% of average snowpack, so 25% down. I just took a look at a little bit of other data, and we are roughly 2 weeks behind if you think about how our snowpack grows. So our current snowpack, statewide at least, and in the Colorado River Basin is roughly about 2 weeks behind it normally is during an average year. So not an insurmountable deficit to make up for sure, but we are behind. So let's take a look at what's going to happen here over the next couple of days. The storm track is generally over us if you are in northern Colorado and look out the window, which is part of the maybe the best way to forecast weather, at least in the near term in big mountains. You can see that it is snowing. It's snowing roughly from kind of the Vail Beaver Creek area and east, and then I-70 kind of in north and extending just slightly down into Aspen. That storm is going to move away this afternoon, but then we have another storm coming in, kind of tracking west to east along where that pink line is from Thursday night through Friday night. So I'm hopeful that most of the state will see at least another 3 to 6 inches of snow. Somebody's probably going to get lucky and get 10, which is a nice 24-hour storm total. So that will be Thursday night into Friday. Unfortunately, then, when we look ahead to the weekend and through Christmas week, the storm track's going to retreat to the north. So the Pacific Northwest will do quite well. Areas to the north of us will do well. Our northern mountains might see a skip of snow, but the reality is that it's not looking super snowy for the week of Christmas. But there is good news, is that the longer term modeling all suggests that in about 2 weeks, we start a stormier, snowier pattern. Now your ears might catch the fact that I said 2 weeks and forecast. You might be thinking to yourself, this guy's out of his mind. How can he possibly forecast or think there's any accuracy going out to 2 weeks? And I want to be very clear that when I'm forecasting out 2 weeks, all I'm talking about is the overall pattern. Stormier, drier, colder, warmer, that type of thing. I am not forecasting that a certain day will be snowy or sunny or warmer or colder, just that the pattern we're going into, hopefully right around the new year or maybe even starting a few days before, will return us to a snowier, colder pattern, at least across the West. Does that translate into a ton of snow here in Colorado? We need some luck, and it's just too early to know. But let's not worry too much about an upcoming kind of dry week or so, because at least here in Colorado, if we get into a good pattern and it snows every other day or so, we can quickly make up the deficit that we currently have. So quick recap, snow coming Thursday night through Friday night, 3 to 6 inches, maybe up to 10 around the state. Probably dry for about a week after that, maybe a chance of a storm around Wednesday the 23rd, but we'll see, not set in stone. And then hopefully a stormier pattern starting just before the new year is the hope. So let's look at the outlook for the season overall. We are in a La Nina season, which simply means that the water temperatures in the Central Pacific Ocean are colder than average. La Nina does not technically mean that the storms will track a certain way. All La Nina means is that the water temperatures in the Central Pacific Ocean are colder than average. However, those colder than average water temperatures often translate into the atmosphere having a certain kind of set of storm tracks throughout the winter. Now, when I say storm track, this is kind of an artist's rendition. There are no railroad tracks through the sky. Storms can track anywhere they want at any time. These lines are just kind of an indication of the general flow of the atmosphere during a typical La Nina season. So when we look back at the last 100 years at other La Ninas that are similar to this one, what we see is those green areas show above average precipitation, which here in Colorado generally means above average snowfall and not necessarily rainfall. So La Nina is generally a good thing, especially a moderate to strong La Nina. In Colorado, you can see usually a storm track coming down from the northwest in some degree, and much of Colorado sees average to above average precipitation. So a typical La Nina is usually pretty good for us here in Colorado. Here's one other way to think about snow for La Nina. Now let me take a moment to explain this graphic. On the left side, the y-axis, the vertical axis, is the amount of snowpack, maximum snowpack for any given season. So all those dots, there's around 30 of them, are the past 30 years, and they're higher during years with more snow and they're lower during years with less snow. Now, in the horizontal axis describes La Nina or El Nino. If you're on the right side in the reds, it's a strong El Nino year. If you're on the left side in the blues, it's a strong La Nina year. And in the middle, it is neither La Nina or El Nino, affectionately known as La Nada. So what you can tell is that there's not much correlation here and effectively zero correlation between El Nino, La Nina, and the amount of snow we get across all of Colorado. If there was a strong correlation, you'd see that average line diagonaling upper left to lower right or lower left to upper right, but there's basically no correlation. However, there is something pretty interesting, which is when we look at the stronger La Niñas that have occurred in the last 30 years, the resulting snowfall during those seasons that I've highlighted here has usually been near average or above average. So basically, the stronger the La Nina, the better chance of us having at least average or even above average snowpack by the end of the season across all of Colorado. So that's exciting and good to know. So just overall, before I get into a little bit of how to forecast snow here in Colorado and wrap up with that, the outlook for this season with a moderate to strong La Nina is that we should, chances, you know, all things being equal, wind up with near average or even above average snowpack across the state. So we're not there now, but hopefully we will get there a little bit later. So let me give you a 3-minute introduction to how to be a weather forecaster, and I'll save you 4 years of going to college. Meteorology 101, we only need 2 ingredients. You need moisture and you need that air to go up. When air goes up, it rises, it expands, it cools, and the moisture condenses into rain or snow. That is effectively all 4 years of meteorology school in one slide. You need moisture, you need lift, and then we get really fun things like snow. So where do we get moisture in Colorado? We get 3 kind of main sources directly from the Pacific Ocean. Storms coming from the west or southwest often bring more moisture and more snow. We have a storm track from the northwest, which brings some moisture, but we don't get as much of it here in Colorado because a lot of that moisture falls as snow upstream. So we do absolutely get snowfall and good storms from the northwest, but the amount of snow we get from each storm on each day with a northwestern storm track is generally a little bit less. And then the big front range storms, when we get a couple feet kind of in Boulder, Denver on the east slope of the front range, that usually, some of that moisture can actually come from the Gulf of Mexico. So that's part 1, moisture. Part 2, lift. And I don't have time to go into all of these things, but there's a fun acronym I made, CLOUD, for 5 ways that the atmosphere lifts the air. And we're going to focus on O for orographics. O simply means that air runs into a mountain and is forced to rise. This is pretty darn simple. No complicated physics involved. That air can't go into a mountain, so it goes up. Snow then falls or rain, and then air comes down the other side, warms up, and dries out. This is a major contributing factor to how we get a bunch of snow here in Colorado. And so since wind direction is key, every different mountain basically has a favored wind direction. What is the best direction for the wind to hit a mountain so that it is forced to rise and not necessarily come down a bigger mountain before what you're looking for. So let me actually put this into a better graphic. So looking at Vail is surrounded by higher mountains on 3 sides. So if air comes from the south, east, or northeast, those red arrows, it actually goes up higher mountains and then descends down into Vail, and we don't want air to go down. We don't want air to go up. So the best way to get big snows at Vail is a wind from the northwest. Looking at just another spot, Aspen, also ringed on 3 sides by higher mountains. So the best ways to get good snow at Aspen is a wind really from the west or northwest. Snowmass can squeak in with a wind from the west-southwest. And let me hit really quickly, because I got 30 seconds left, on climate really quick. Jim already mentioned that we are an arid state. I like to remind people of that. This is a graphic put together by Weather 5280, which is a great front range weather blog. The orange line shows temperatures across Colorado, which have warmed in the last 80 years. But the blue line shows, or the blue bars show average snowpack, which has not changed very much. And so what this means, 3 bullets to close it out. Temperatures have increased in the last couple of years, and they'll likely continue to increase. Precipitation shows no trend in the past, and there's low confidence in the future. Doesn't mean there won't be a trend, but we just don't know. And there's my timer. And then the last bullet, warmer temperatures. So even if precipitation doesn't change, warmer temperatures still mean less snow at lower elevations and earlier snow melt, and it could exacerbate drought conditions. So just keep these bullets in mind, because if we get good or bad snow years in the next couple of years, we do not conclusively know that that is linked, good snow or bad snow, to any change in climate. But we do know that temperatures have warmed and will continue to warm. And then here's just a little plug for OpenSnow, and I'll be around for questions a little bit later. Thanks, everyone.
Thank you, Joel. I already have a couple questions for you that we'll get to later. But now we're going to transition to our other speaker who's going to provide some basic information about predicting the harvest. As I mentioned, Paul is a hydrologist with the Colorado Basin River Forecast Center in Salt Lake City, where they think they have the greatest snow on earth, and they like to diss Colorado. Not you, Paul, but your
I'm not a skier. I'm from Vegas, so don't
there
worry.
you go. And prior to, and part of his job at the Forecast Center, he's a climate focal point for the office, and he got a good background in that because before 2012, he worked with the U.S. Bureau of Reclamation in the Lower Colorado region for about 7 years, investigating the impacts of climate change to the Colorado River Basin. Paul's got a great education with advanced degrees, and I'm going to swing it over to you, Paul, to tell us about the Forecast Center and how you do it.
Thanks, Jim, and thanks for having us here. We like to do outreach whenever we can to our.
Paul, you're muted.
There we go. Thanks, Jim. Like I said, muted. That we do like to do outreach whenever we can to stakeholders, and that's the primary aspect of my job. Lots of text here, but the big takeaway from this presentation is that we provide lots of products and services, and we'd really like to work with all of you more closely to get you the data that you need and help you make the decisions that you're trying to do. Last year was pretty dry, and so we've got some dry fall soil moisture conditions, and so far it's been a very dry year. So there's cause for concern, but there's so much climatic variability in this region that things can change. So just a quick overview of who we are at the River Forecast Center, and I'll give you a quick summary of our water supply forecasts and how we make those forecasts, and then conditions so far. So we're one of 13 river forecast centers that are located nationwide. We're co-located with the Salt Lake City River Forecast Center, and they're the ones that'll send out the flood alerts to your phone or scroll across the bottom of your TV or your radio. We're in the background of those public messages. We're providing support. We let them know how long we think the flood's going to go, when it's going to peak, when it's going to recede, that kind of stuff. In the West, the river forecast centers are really adept at forecasting water supply. And like Jim and others have mentioned, it's mostly snowpack driven. So we work with a really broad and diverse set of stakeholders, federal agencies, municipal and agricultural water users, state, academic, NGOs, even some tribal communities. It's an aspect that we're trying to work more closely with. And one thing I'd like to point out is that we are data consumers. We rely so much on information that's provided by so many of our stakeholders. Many of them, I'm sure, are on this call. We don't have our own data network. We don't monitor or do our own data collection. We go and get all this data, and it's given to us in a variety of ways, and we put that into our model. Like I mentioned, we work with the weather forecast offices, and they're really a key stakeholder. They're the ones issuing those watches, and we try to be very flexible with them. We can go to 24 hours operations if there's a hurricane remnants or anything coming through, which we've done, probably about once or twice a year, every year since I've been at the River Forecast Center. And the WFOs are a great local point of contact for you all. So if you're an emergency manager and you don't know who your local point of contact is, let me know and I will get you in touch with them. So our water supply forecasts are probably our most popular forecast. This is a screenshot from last year just because we haven't started to issue our forecasts yet. We start in January. But they're probabilistic, so you get a sense of risk in what you're intending. You can kind of see what your level of risk is for your particular operations. You can see what we think the range of forecasts will be. We also give you a most probable one number kind of thing, but probabilistic forecasts seem to be the direction folks are going. We provide this at monthly and seasonal time steps. Our April through July forecast is probably our most popular forecast. But we even work with reclamation to provide up to 5-year forecasts. And it helps those water managers make decisions with regards to their reservoir operations. For those of you, especially in Colorado, that span multiple river forecast center boundaries, we do have a Western water supply forecast map. And you can see all of the forecasts in the West all on one nice page, which is really handy. And we link to that off of our website, and it's nice. So just to give you a background on how we take in all this information, we use a hydrologic model called the Sacramento Soil Moisture County Model, and that's coupled with the snow accumulation model called Snow 17. I'm not really sure where they came up with the 17 acronym part. But the calibration of it is really highly dependent on gauge observations. We spend so much time QA/QCing gauge data every morning, and it's a big part of our job, making sure that good data is going into our model so that we get quality forecasts coming out. And poor Joel with his bad forecast. Hopefully we're not in that conversation with that forecast. So there's just a quick little schematic of it. But what I really wanted to point out was that, you know, it's a lumped model, it's continuous, it's conceptual, it's a relatively simple model, but compared to some of these really robust, very high computational cost kind of models, we perform very well with them. Gauge data, like I mentioned before, is so vital. The data that we get from our partners is really important to us. Like I said, good data goes in and we can get great forecasts out of our model. Forecast information, we work again with the weather forecast offices to bring in forecasted precipitation and temperature data. We work with reservoir operators to get their planned operations, and diverters, how much water they're taking off of these streams. So again, we can provide accurate forecasts. So in just developing a forecast, we have forecasters that look at I think we forecasted about 500 points every day, and we're looking at every single one of those points at least once a day. So our forecasters go through that model, and we look to assess the quality of those historical and future foreseeings. We look at the observations, we look at how the model's been doing, and then we can make any adjustments, and we make sure that they are physically based adjustments. They're not just like, I feel like bumping up the forecast today. It's not like that. We really strive to have a physical basis between any kind of changes we make. This is a schematic showing how all that data feeds into it. We've got this observed data, our forecasted operations, model parameters like soil moisture and evapotranspiration and other information that goes in there, and then objective, physically based interaction with our forecasters, making what we call modifications to the model in near real time. This is what we look at when we're looking at the model every day. This is the Green River up in Wyoming. I guess I should have picked a Colorado point. But you can see the observed data from the USGS and what our forecasts look like, and we can kind of assess how temperature and precipitation forecasts are doing. Those green bars up there represent snow melt in May and the effect that has there. So we're looking at this again, at least once every day, even more during times of hydrologic activity. When we make our water supply forecast, we get our model behaving as best as we possibly can. And there's a lot of text here that you really don't need to spend a lot of time reading. But basically what we do is we get our model set to be the best possible representation of today's current states as we possibly can. And then we cycle through all of the historical precipitation and temperature trends or observations back to 1981 through 2015. So you get 35 possible hydrologic futures. And that's what comes up with that big range that I showed earlier. And as we get more information about the snow, about the temperatures, as we get more and more closer to that April through July runoff period, that range gets narrower and narrower and narrower as we get more information. And so this is just, you know, looking at all those, what does all those 35 traces look like? And this is over at Durango on the Durango River. And, you know, initial conditions in January 1st, we don't know a lot of stuff. There's still lots of unknowns. And then as we get closer and closer to April and we get into what we're calling our forecast period, we get more and more of those knowns, and we feel better and better about our forecast. And then we issue those forecasts based on the exceedance probability. So that 50th percentile, that median value of all that ensemble of traces, that becomes what we call our most probable forecast. That's like that one number value that we send out. But we make all these traces available. So if you want to take all 35 traces and do any kind of algorithm or weighting scheme or anything like that, you can totally do that. So ideally, how we see ourselves fitting in is we create these reservoir inflow forecasts here in the green box. We feed it to our users and our stakeholders who put it into a reservoir model or any kind of water operations management model. They come out with forecasted pool elevations or target elevations or target flows if you're an environmental, if you're focusing in on environmental aspects maybe. If those outcomes are great, hey, we're all good and things don't change very much. But if those outcomes aren't so great, you know, maybe there needs to go back and be a change to that operations model. Maybe the weather changes and then there's a change to our forecast. All these things kind of work together. So it's a cyclical process. Again, we like to talk to our stakeholders a lot to make sure that we're providing information that's timely and relevant and meeting your needs. So we send all this information out to our website. It's cbrfc.noaa.gov. And there's tons and tons of information on this website. It's not always intuitive where something is. So I would really ask you that take a look at our website, play around with our website. If you don't find what you're looking for, it doesn't mean that it's not there. And it also doesn't mean that we don't have it. So we might have it, it just might not be on our website. So get in touch with me and we'll do our best to get you the data or show you where it is on the website. So what do our current conditions look like? Like I mentioned before, we had a really dry fall. These dry soil conditions reduce runoff efficiency. It's below average everywhere, but snowmelt needs to replenish these dry soils. Precipitation amounts so far for the water year, also well below average. This is the primary driver of our stream flow. And so it's not looking great so far. And then I also wanted to show what our modeled snow conditions are over the model. And again, well below average. So our initial forecast, which we will begin officially issuing in January, will probably be below average unless there's a big change between now and the end of December. But what I would encourage everybody is tomorrow we have an early outlook webinar. You can register for it here. You can get an early preview of what our forecasts are going to look like. Cody Moser in our office is really great at presenting this stuff. And I would encourage everybody here to register for it and take a look at what we're thinking the early forecasts are going to look like. We did a model sensitivity analysis, and this report and data is all available on our website. And I'd love to answer any questions about this because I wrote the report. But we looked at how all these different parameters and variables play a role in how our forecasts are impacted by our forecast. And you can see precipitation has the biggest impact, but soil moisture, evapotranspiration, temperatures, all play important roles, sometimes at different parts of the year. So just to conclude, the CBRFC is a really great resource, and we try to be a great partner, and we can provide information to aid in your decision making. It's my job. It's to talk to stakeholders and make sure that we're getting the information out to you in a format and in a way that that is good for you to use. We really strive to be open and accessible and transparent. You know, we're all about building trust. So if you don't understand how we're making our forecasts, we want to help you understand how we're making those forecasts. And the current conditions are dry, but there's lots of variability in our region. And I mean, Miracle May was like 3 or 4 years ago, and we can't really rule out a whole bunch of stuff right now. So with that, here's my contact information. And again, that early outlook webinar, maybe Jim or someone can put that link in the chat or something like that. But I think it's probably a really good resource for this group. You've probably gotten notifications about it. But if you haven't, I'd encourage you all to attend. And thanks.
Thank you, Paul. And I concur with the value of your webinars. I'm sure that most folks on this call are either weather geeks and snow geeks and runoff geeks. And this is a great place where you can really take a deep dive. So thanks, Paul, and I'll have some questions for you later. And I do want to remind the audience that please pose questions in the Q&A. I see some, but we'll have time to address them and more. So now, after learning about science and meteorology of snow forecasting and forecasting runoff, we're going to get to the reality of what happens on the ground. Our first speaker is Alan HENCEROTH. Alan grew up in Tucson, Arizona. He completed a degree in forest management from Northern Arizona University. He went to work at Keystone Ski Resort in Summit County, and he moved to ARAPAHOE Basin in 1988. He's been a ski patrol director, director of mountain ops, and since 2005, chief operating officer. Importantly, right now, he's board chair of the National Ski Areas Association and the National Avalanche Foundation. Alan enjoys playing in the mountains and canyons with his wife Kay and now adult kids, and his favorite winter fun is skiing the Spine at 8 Basin, and yeah, why not? And hiking the East Wall at 8 Basin, and that's fun too in late season. So, Alan, take it away.
Well, Jim, thanks. Boy, in some ways, Paul's presentation and Joel's presentation really are a lot about what we deal with on a daily basis. And snow and water, we work with and deal with, and it impacts us in multiple ways. Obviously, people know that when it's snowing, people go skiing. When people go skiing, we do business. Our business primarily is running the chairlifts, but we do a lot of other things. We have restaurants, we have a ski school, we have a rental shop, we have retail. We do all kinds of fun special events. But the snow has a huge impact, and the way the snow varies has a tremendous impact. And I mean, I'm almost embarrassed to let Joel know how many times each day that I check his website. And it just means so much to everything we do, how we respond to any kind of weather event. And and the snow, it is almost automatic. If we get 6 inches of snow on a Thursday, we can guarantee the next day is going to be good and Saturday is going to be huge. And the impact is very real. We spend a lot of time managing that snow. When it lands in the ski area, we want to keep it there. We don't want it to blow away. We try to pack it down. We have people out on foot on skis packing snow down from the time there's 10 inches of snow on the ground. We get our snowcats on the hill packing snow as much as we can. We have a really aggressive snow fence program where we try to take advantage of drifting snow and put snow where we want it. And a good snow fence can function better actually than a good snow gun in terms of its impact on us. So I know I'm not telling you anything, but snow is real. We count on it for everything. We're open in the winter for about 7.5, 8 months each year. We have a budding summer business where we're open for almost 3 months. But really, it all comes down to snow, getting people out there, sliding on the snow, moving on the snow. The impact is extraordinary. We have Arapahoe Basin is a fairly steep ski area. We have a very aggressive avalanche control program. We have 3 different weather stations within the ski area where we're collecting data. And our snow safety team is, they get here about 4 o'clock in the morning, the first person goes. And they check the weather stations and they essentially make the plan for the day for how we're going to go on. Snow for us, it's everything. It is literally everything. We also have, we also, each day through the winter, we'll have a few thousand people show up. And so we have, although we don't have lodging, we have a whole lot of toilets. We have several restaurants, several kitchens, several dishwashers, and we have a pretty significant demand for domestic water that maybe people don't realize. We're kind of at the head of our own little basin in the North Fork of the Snake. In terms of water utilities or wastewater utilities, we're self-contained that way. We have 2 drinking water plants, one in the base area that taps the North Fork of the Snake for surface water. And we have another mid-mountain for our restaurant up there where we have well water and we treat the water up there. And then down at the lowest point in the ski area, we have a wastewater treatment plant. So we work closely with all the appropriate authorities and officials, Colorado Department of Health more than anyone, on running 2 drinking water treatment plants and a wastewater treatment plant. And you know, snowmaking is a big deal. It's a big deal when it comes to diverting water. It's a big deal for how we operate. And probably some of you on the call may remember back starting in the middle 90s, we went through quite a lengthy environmental impact statement to get snowmaking approved at Arapahoe Basin. We were one of the last areas in Colorado to add snowmaking. And we have a relatively small but very efficient snowmaking system. You know, it involves a diversion point. It involves a small reservoir. We have a couple of pump stations. We have a water pipeline and an electrical system that runs from top to bottom and with a few spurs other places. And, you know, snowmaking has been fantastic for us. We spent the summers of 2002, 2003 in installing snowmaking after that lengthy NEPA process. And it's enabled us to have an average opening of about mid-October because of our snowmaking. And it's helped us in a few ways. And pre-snowmaking, we would open sometime between Thanksgiving and Christmas. We never knew when. We'd just be out there in the base area looking to the west and northwest on our hands and knees praying that weather would come. And now we have a little bit more, a much more reliable way to get things started. You know, our business still moves up and down, but we filled in the troughs substantially. So when it's not snowing, snowmaking gets us, it gets us started, it gets us open. Of our 1,400 plus acres, we only have snowmaking on about 100 acres, but it is in those core areas, the most heavily used. So we can get up and we can get going. You know, we've been able to put a whole lot of people, not just the snowmakers, but it's allowed us to do so much more. And pre-snowmaking, we literally had about 7 year-round employees. And snowmaking enabled us to just be so much more reliable and so much more dependable to staff and to our business. It's allowed us to do a whole lot of other things too. It set the stage for some terrain expansions, building of additional restaurants. And you know, now we're up to 150 people that work in the summer as well as the winter at the ski area. So I just can't say how critical snowmaking is for us. And both Joel and Paul mentioned what a tough, dry fall and summer it has been. We really felt this even in our snowmaking because our diversion rate for snowmaking is really dependent on how high our stream flow is. The more water in the stream, the more water we can divert. The less water, the less we can divert. So we really took a beating. The stream flows are quite low, as you know, and this year our snowmaking is going to end up being about half of what's average for us. So it's a really big impact for us. So I'll close out with that and turn it back over to you, Jim.
Thank you, Alan. The moral of the story is water's everything.
Water is everything.
And that's so true across the arid West. And that's really the #1 message of the River District, especially for newcomers. So now we're going to segue into what happens with snowmelt that Paul predicts with Todd Hagenbu. He's the Colorado State University Extension Agent in Routt County. He's a 4th generation of his family to ranch in Routt County, and he understands firsthand the challenges surrounding ranches on the West Slope. And with that, in the interest of time, Todd, I'm going to throw it over to you.
Thank you, Jim. I appreciate that. There we go. Thanks, Jim. And I'll try to make this quick because I want to get to our participants' questions for sure. But I want to share this photo of me and my family in South Route, enjoying that snow that we're talking about today. I am not a skier. If any of you on the call just had heart palpitations on that, I totally understand. But I do love to snowshoe. So that's us out enjoying snowshoeing in Colorado's finest powder snow in Routt County. Quickly want to give just everyone a little background on agriculture. And we know that really what we're talking about in snow and the climate in general is variability and how we're adjusting to that. Agriculturalists have been adjusting to variability in the climate for years. And some of the ways we do that is by not running our ranches at capacity or our forest permits or our BLM allotments, et cetera, making sure that we have a little insurance policy in terms of the amount of grass that we have. We carry over hay or other feedstuffs to ensure that we can get through those drier, leaner times, or irrigation, which I'll talk more about here in just a moment. But we also have to consider as ranchers that we've got a genetic resource in our cows and our ewes, whatever that livestock is, that we've worked for generations on. And so you just can't take care of this problem by selling those animals, because that's a genetic resource that you've worked a long time on. Also, there's timing. If a cow's just had a calf, you can't just ship her because you know it's a dry spring and that you're looking for a summer that's going to be tough from a range perspective. You have to keep that calf on that cow, and shipping and moving around these animals at particular times is more than difficult. And of course, there's markets. We're price takers, and when times are tough, unfortunately, the market tends to be tough because everybody's flooding that market. So we have to keep that in mind too. So I want to go back to irrigation and how we use irrigation as the major tool we have to mitigate variability in our climate. In Routt County here, in particular in the Yampa Basin, the upper Yampa Basin, bear in mind that initial water storage was for irrigation. Of course, we can look at our friends on the east slope too, and transbasin diversion projects that take water out of the Colorado and send over to the Front Range. Those were all for irrigation and helping our farmers and ranchers mitigate climate differences. So very small reservoirs in the upper Yampa Basin. We've got Stillwater and Allen Basin, Yamcola, but even Stagecoach, which is the largest big bucket that we've got at a little over 33,000 acre feet, was originally envisioned for irrigation. But what's the major way we store snow in the Yampa Valley? And that's through snow, which is the purpose, of course, of this webinar. Here's the Windsor Ditch on Walton Creek, just outside of Steamboat Springs in June, and here it is in October. That's, of course, because there's no snow to feed that. So that just exemplifies how snow is our major storage vessel. So things I want people to consider as you're looking at the questions you want to answer, or just think about it the next time you drive over Rapid Ears Pass into the Yampa Valley. What did all these mountain valleys look like prior to the advent of irrigation? Certainly less production, and also a little species change in those mountain meadows. Now, most of those mountain meadows have not been plowed. They've maybe been seeded with some additional varieties, but more bunch grasses, not sod forming grasses. And we had potential for more erosion. Irrigation has helped create that green valley that you see that has created a real economic driver in our western valleys. And then I also ask these questions of you all. How does irrigation impact the growing season storage? So we store it as snow in the winter, but we also slow that water down as we fan that out across meadows and then store it in our alluvial soils throughout the growing season. And then it is released slowly back into our river system. So then if we quit irrigating, how do we impact downstream users? Paul mentioned Miracle May. I know that when we had that Miracle May, I think that was in 2015, people didn't turn on the irrigation ditches. They had no need to. And if you talked to ranchers down near Maybell and lower on the Yampa River, they said we didn't have water later in the summer to irrigate with because those return flows hadn't been slowed down across those meadows. So they were greatly impacted by what happened in the upper basin. How have we impacted riparian health, especially as we don't have those return flows and we've created an ecosystem now in riparian areas that depend on return flows? How will that change if we don't irrigate as we used to? And then also our expectations. People expect to see green meadows and it's worth value to them. Colorado State University did a study in the last decade that looked at what people are willing to spend as tourists looking at open ranch land. And while it was primarily looking at the conversion of that land, if we don't irrigate and we can't make an economic case for keeping ranches and farms viable on the West Slope, they will essentially go to urban or other development. And the impact at that time, which again, this was several years ago, was over $11 million to the Routt County economy for people enjoying these scenic vistas. So if we don't irrigate, how are we impacting that? Our local fly fishermen, wildlife that depends on these irrigated grounds, and our hunting. So it's widespread and not just agriculture. So I'll leave it at that, Jim, and look forward to the conversation that you're going to facilitate now.
Okay, thank you, Todd. And if all our guests can turn on their cameras. But, since we have Todd talking about the Yampa Valley, I'm thinking about the snowpack chart that Joel showed earlier, and the Yampa Basin had way above average snowpack last year, but then we come into the summer and we have the second ever call on the Yampa River. I know a lot of folks are going to say, what, only the second call ever? We have calls every day of the year in some areas. So, maybe Paul can help, and Todd, you can tell us about what happened on the ground, but where did that snowpack go? How did above average snowpack become below average runoff and then basically turn off?
I'll say real quick, and then I'd love to hear Paul's perception of this as well. But I can tell you that ditch picture that I showed you, we got hot early. We had increased evaporation, and the grasses, of course, were growing quicker. People were getting water turned on quicker, so evapotranspiration was higher. But really, it was the heat that killed us this spring and early summer in terms of losing that water. That ditch that I would have normally been able to have irrigated out until late July for the crop, I couldn't get water to the head gate after July 8th. And certainly, I did not have enough growing season to then produce a viable crop. Paul, did the data prove that as well?
Yes, and I think last year going into January and even early February, we did have like normal snowpack conditions, and I think folks got really comfortable, and I think they saw the initial forecasts that were near average. But yeah, after about mid-February, things really dried up and they really heated up. So we had some really warm periods there, and then the precip just stopped. We did not get the type of precipitation events that we normally get, and that's really what drove the forecast down, was we just didn't get the rain that we usually get.
So Joel, my experience seems to be that we get these high pressure ridges just setting up, in summer and sometimes in winter too, that block our precipitation. What's going on with these persistent highs?
Yeah, it's a bummer, huh? It's so there's kind of two schools of thought, I want to say, and it's not, science is never that simple, right? Where there's just two schools of thought, but there are some folks that think it's more transient and it's basically bad luck. It's natural variability is the scientific term. And I just read a paper that had come out by some researchers in California looking at the ridges, which they call the triple R, the ridiculously resilient ridge, I believe is what they say, where they have noted that there's some propensity for those ridges to be more frequent and stronger in more recent years, or at least more recent decades than previously. So I read some of the paper. I'm not going to quibble with it. I'm not sure it's that cut and dry. And I think to some extent, meteorologists, hydrologists, we do a really good job, especially compared to 30, 40, 50 years ago. The science has come a long, long way. But I don't think we can overstate how much natural variability there is. And sometimes we can explain it, and just sometimes we don't know yet, or we don't know with a lot of confidence. And so I looked at one other study that was looking at if ridges and troughs, basically high pressures and storms, are theoretically getting more variable across the world due to warming temperatures, especially at the Arctic. It kind of throws off the jet stream theoretically, or changes the jet stream, I could say. And the study I looked at that was published within the last year basically didn't find global evidence that was occurring. So we may see the science emerge that the ridges are more frequent or stronger and leading to dry weather, but I'm not, after reading some of these studies, I'm not kind of sold yet. So we may just be in a bad luck period at this point as well.
So, Alan, we've heard talk about warming temperatures on this webinar, but I'm going to personalize it. Of course, I like to ski, and it's always a sad moment during the ski season when we start getting freeze-thaw cycle and spring skiing. I like that cold snow as long as possible, but it seems like spring skiing is starting earlier and earlier. You operate a ski area. What do you see?
And it's especially true for us because we're operate a ski area that goes into June every year virtually, and every once in a while July. You know, there's a great opportunity for a scientist to take our data and do a great study, but there's no question spring's coming earlier. I think those guys down at the, I believe it's called the Rocky Mountain Biological Laboratory down near Crested Butte, they've got some great studies that show spring's coming earlier, but we can tell you for sure. You know, we work harder now to stay open later than we did 20, 30 years ago. There's no question about that. It just, spring comes earlier. It seems like that first melt freeze date comes earlier than it used to, and it's real. It's real.
Appreciate that. So Joel, you mentioned that some storms can really catch us up. We're about 2 weeks behind now. We've heard about atmospheric rivers over time, and Alan would like that. I would like that. Anybody who's interested in snow and water supply loves atmospheric rivers. What are they?
So an atmosphere, and Paul, I would defer to Paul too as the hydrologist, but an atmospheric river in simple senses is just a push of moisture directly from the Pacific Ocean, a part of the Pacific Ocean that brings a lot of moisture into oftentimes California, Oregon, and Washington, but sometimes that river of moisture can push further inland into Utah, into even parts of Colorado, sometimes into Wyoming. They are often responsible for very large increases in SWE, snow water equivalent, not always responsible for the best skiing due to both, you know, when you get a lot of snow in a short amount of time, that can increase avalanche risk, but also the moisture is often associated with some warmer temperatures, so the snow can sometimes be a little thicker, heavier. But even though it may not be perfect for ski quality, it can rapidly increase our snowpack, and it's great for the water supply.
Thank you for that. Here's a question from our audience, and generally they're wondering about the efficiency of snowpack. So, you know, on average, of all the snow that falls and the moisture it contains, how much of that actually gets into the rivers and creeks and streams? Anybody?
That's a Paul question, maybe?
Yeah.
And that's a really tough question to answer. So a lot of it depends on the temperature and how it happens. For instance, if we have a very cool spring that keeps the snow up in the mountains longer, and then a very quick warm up in the summer, we can get a very efficient runoff because that runoff comes off very quickly all at once, and you don't lose so much to evapotranspiration or sublimation or replenishing the soils. If we just have very warm conditions from the get-go, we could have something like what happened last year, where we lose a lot of snowpack to sublimation and evapotranspiration and to the soils. So it really depends a lot on the temperature profile. It depends a lot on the antecedent conditions. So if we have very saturated soils before things start to melt, we can get a much more efficient runoff. So it's very condition dependent. Yeah, I don't have a good number for that. Sorry.
You know, that's all right. Our attendee who posed the question was thinking it's around 15% on average. Yeah, yes, there's all these variables. Indeed, Eric Kuhn used to be general manager of the River District.
Oh, yeah, I know Eric. Yeah.
Yeah, he would. It's not as high a figure as a lot of folks would think. So, you know, a lot of that, as we've talked about, that snow's going into the soils, it's going into roots, it's evapotranspirating, and the efficiency, even in the best of times, is not what you would think it would be.
Yeah, and I think that's a really good point. I think it just underscores that you can't assume 100% snowpack equals 100% runoff. There's all these other processes going on between snowpack and what you see in the stream.
We have about 10 minutes left. Here's a quick fun one for Alan. When's the Pally Chair, the new Pally Chair, going to open?
I can't believe they asked me that one. We're getting very close on Pally Chair. It's new lift, fully licensed and ready to go. And I went skiing up there yesterday. We're close. Pay attention every day.
Good. So here's another question about soil moisture monitoring technology. And you know, how does that work? And is it expanding our ability to forecast water, soil, or water? Oh, my screen's jumping around, but how does it affect forecasting? So I guess that's a Paul question, but soil moisture, but it really, you know, Todd, if you have a follow-up on real life experience. So.
Sorry, it cut out a little bit. Could you repeat the question?
Okay. The question is soil moisture technology, and is it advancing, and how is it helping us forecast or discount runoff?
So that's a really good question. So in our model, the soil moisture is it's not really represented by a gauge. It's not something that we use measurements for. We basically calibrate that using base flow conditions that are happening during the fall. When there's not a lot of diversions, there's not a lot of runoff, we basically back calculate that parameter. And the reason we do that is because our model is trying to represent very deep soil moisture conditions, like on the order of like 3 to 4 feet in the ground. And there's not a lot of sensors that can easily be installed at those depths, especially at high elevations where you get just even a few inches in and you're hitting bedrock or granite or gravelly kind of soils. That being said, there's been a lot of advancement on remotely sensed soil moisture conditions that do kind of sense these deeper soil moisture characteristics. And we're looking at those, but so far we haven't found a data set that really correlates with what our model is trying to represent. We found a few gauges here and there that do have very deep soil moisture sensors, and those sensors do correlate well with our parameters, but right now it's really hard to incorporate an observed soil moisture data set into our system.
So Todd, as a rancher, this will be the second summer of second snowpack starting out on top of bad soil moisture.
Absolutely. And, you know, I'm interested in what Paul's saying about that data. Certainly most of the data that CSU's looked at is more looking at soil moisture from what does plant growth impact and how do plants interact with that soil moisture, and not looking at how this runoff situation is impacting it. But certainly from an agriculturalist perspective, I'm worried about range conditions as we move into this year. Not only are we going to see less water going down into the streams because it is going to be going into the ground, but our plants are thirsty. And of course, depending on how shortly we're grazed this fall, will depend on how they're going to grow and react this year. But we had a pretty rough range year this year, and we're probably setting up for another one in 2021.
Thank you. So a friend of the River District, Jeff Lucas of Western Water Assessment at the University of Colorado, he's chimed in with the efficiency of snowpack. And he said of snowpack, or efficiency of precipitation in general, but if snowpacking can be 50 to 70% efficient, but when you consider all precipitation, 12 months, it is closer to 15 to 20%. So there's a little bit of clarification on runoff efficiency. Looks like we have 5 minutes left, and here's a cloud seeding question. Of course, cloud seeding's been in the news lately because a chief funding source from Vail Resorts was cut off this year, and you know, that's a pandemic financial related. But generally, how do we view cloud seeding as an important ingredient in the snow picture? And Alan, maybe as somebody who would hope that cloud seeding is really working in your region, are you a believer?
You know, I am a believer on a really broad scale, but I'm certainly not the expert to be talking on this. But you know, my understanding is that it can add a few percentage points on snow, and it doesn't just create snow out of nowhere. You have to have a storm coming, and you might get a little more. It's explained to me. We did participate for a year or two alongside Vail in that cloud seeding program. And we just, to be honest we couldn't make the connection with what we were paying to be part of it and whether we were really getting more or less snow. And we eventually stopped doing it and bought a few more snow guns with the same money. So I do believe it on a broad scale, particularly an organization like Denver Water that's trying to, you know, get more water into Lake Dillon. That makes great sense. But we've had a hard time making the connection for our small little place.
Well, one point about cloud seeding is you actually need clouds to seed.
Yeah, exactly.
So that gets in. Yeah, go ahead, Joel.
Well, as you say, the research is somewhere between maybe 3 and 10% improvement in snowfall in a well-seeded cloud that has a good setup. You know, maybe on average a couple percent to 5%. But the point that you made is that this doesn't come out of nowhere. You have to have a storm with the right wind direction, right amount of moisture, the right temperatures, and then you can see that. And in those situations, it can lead to a few percent more snowfall. What I generally tell people, at least from a skiing perspective, is that seeding is not creating a powder day from dust on crust. You know, it's not turning 2 inches into 10. But over the course of a winter, if you increase a 300-inch winter into 315 inches by increasing it 5%, that's a good bit of water in the spring. So there is, as Alan mentioned, general utility in all of this, but I can imagine the variability from kind of mountain to mountain, and is there an impact is quite variable.
Yeah, you know, and part of our thinking was, you know, there's the cloud seeders, the actual machines, and you might get 300 inches, but that's assuming you got the cloud seeders out there in all directions that the wind is coming from. And you know, in reality, it might be in our situation, although there was a lot of them at that time, but that 300, I don't even know that we thought it could be 315. It might be 305. We just couldn't justify it.
Well, there are people who do believe in it and invest in it, and those are our friends from Arizona, Nevada, and Southern California, and they're major contributors to cloud seeding in Colorado, especially when you think of that map I showed early on, where the relatively small area where snow falls. Their hope is as much snow falls as possible, and given the science that Joel mentioned, and I know from our own shop that it's considered cheap water, and it's a good enough bet to keep going. So we're actually almost at close. Would anybody want to make a quick closing statement?
I'll do my best to answer. There were a few questions looking for sources and references. I'm going to do my best to get those out, or I'll send them to you, and you can send them to the group.
Yeah, we do have lots of great questions. This could go on forever, but the magic is it's water for lunch, and lunch is almost over. And Alan needs to go ski. But given that, I will thank Todd and Paul and Joel and Alan for joining us, and as well as the many folks who tuned in and posed the questions. And we indeed will try and get the best answers we can. So that concludes this Water for Lunch, and think snow for all the reasons we just heard about today. Thanks.
Thank you, guys.
See ya.
Bye, everyone.